Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izan bin Shahidan. My metric number is AA191976. So today I'm going to continue with Engineering Lab 1, which is porosity and density. So we're going to continue with the additional theory for this lab. So basically, the volume of pores is calculated from the weight of the liquid which needs to fill up the pores. But by using this technique, there are still pores which couldn't be filled with water. So, uh, the accurate volume of pores cannot be determined using this particular technique. There are another way to determine the volume which does not require to give any solid density value of bricks or porous material, as there may be certain parts of pore that cannot be penetrated by the liquid. So, to obtain the true density, the solid material would have to be crushed into a powder form, which consists a lot of small particles to diminish the pores. So, the properties could be determined from three weight determination. As you can see, the first one is weight of dry specimen, then weight of specimen which has been immersed and suspended in water, and the last one is weight of specimen which has been immersed in air. So the formula, there are currently two formula to find the apparent porosity and the bulk density, as you can see, and the result for this experiment I already put it into a table form. So here is the result. I think that's all from today. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rizwan bin Sutimin. I will present about the objective of this experiment. Okay, the first objective of this experiment is to find out the relation between specimen texture, the properties, bulk density, and porosity. The second objective is to determine and differentiate the material bulk density and true density. The third objective is to define the porosity and density of the sample. And the fourth objective is to make an observation to the sample in the experiment. And the fifth objective is to perform calculation involving bulk density, particle density, and percent pore space. Okay, right now we will discuss about the observation on porosity and density experiment. Okay, there is a several problem happen on this experiment on that cause a problem toward the result. Okay, there is a several problem. The first one is the temperature inside the laboratory causing the changes of the result. Okay, it happened when the temperature inside the laboratory is lower than the outside, and it influence the cooling process that happen on the specimen. Okay, the second problem is when when they were using the weight scale, they cannot fit the case with which is they need to use the weight without the case, and it allow the outer atmospheric pressure influence the weight scale to give to do a changes in the scale. Okay, the last problem is the thread was too hard to handle and very fragile. Okay, and that point they were using a thread that was very tiny and very hard to handle, which to tie them up into a very um in a very good condition to avoid any mistake or any failure on that experiment. Okay, the learning point from the experiment is the porosity depends on the property of the food material and drying process condition. Okay, the food material is the material that we consume every day, like glass, wood, or metal. Okay, the second learning point is porosity affecting several properties of the material, such as material property properties, durable properties, chemical properties, and mechanical degradation of materials. Thank you so much.
Hello, Assalamualaikum. Saya Muhammad Yusuf Nabil dan saya akan bercakap tentang apparatus, lab, density dan porosity. Ini adalah apparatus tersebut. Kita ada precision balance untuk menimbang berat material selepas dan sebelum eksperimen. Dry box untuk memastikan material kering sebelum digunakan. Beaker untuk diisi air bagi submergekan material tersebut. Benang untuk suspend material dalam air. Kemudian kita ada aluminium plate ataupun plate aluminium, kuku besar steel nail ataupun paku besi, glass block. Kita juga ada glaze tile ataupun juga yang telah diglaze, refractory ataupun penebat haba, tile penebat haba, dan juga brick atau batu bata. Jadi apparatus akan disetapkan seperti ini, di mana keseluruhan benda ini akan diletakkan dalam precision balance, dan kemudian material akan disuspend dengan menggunakan benang dalam beaker berisi air. Material tersebut akan ditimbang sebelum dilakukan begini, semasa dalam suspend dalam air, dan ketika suspended in air ataupun udara. Jadi ini adalah result eksperimen tersebut, di mana saya akan bacakan. Untuk spesimen aluminium, steel dan glass, aluminium ketika kering, beratnya ialah 3.21 gram. Ketika disuspendkan dalam air ialah 3.46 gram, dan suspended in air is 3.2 grams. Untuk steel pula, spesimen kering ialah 1.46 gram, apabila dalam air ialah 1.92, dan apabila disuspendkan dalam udara ialah 1.44. Untuk blok kaca pula, apabila kering ialah 5.23 gram, apabila dalam air ialah 6.06 gram, dan apabila digantung di udara ialah 5.17 gram. Ini pula ialah result untuk spesimen batu ataupun untuk porosity. Ini saya akan bacakan result. Untuk glaze tile, spesimen kering ialah 3.13 gram, apabila di dalam air ialah 3.59 gram, apabila suspended in air ialah 4.01 gram. Refractory pula ialah 12.8 gram apabila kering, 13.4 gram apabila di dalam air, dan 14.12 gram apabila digantung di udara. Untuk batu bata, 20.43 gram apabila kering, apabila dalam air ialah 23.57 gram, dan apabila di udara ialah 23.84 gram. Saya akan bacakan soalan discussion. Jadi untuk discussion, saya ditugaskan untuk mengira bulk density dan apparent porosity of each materials. Jadi formulanya ialah, untuk bulk density ialah bulk density equals to berat spesimen kering dibahagikan oleh berat apabila dalam air darab pada berat di udara. Jadi inilah formula untuk bulk density. PD equals to WD over WW times WS. Ini pula ialah untuk porosity, WW times WD divided by WW times WS. Jadi result untuk bulk density dan porosity bagi aluminium ialah, untuk bulk density ialah 0.29 gram dan porosity ialah 0.93. Untuk steel pula, bulk density ialah 0.53, untuk porosity ialah 0.76. Glass block pula ialah 0.17 bagi bulk density, 1/01 bagi apparent porosity. Untuk yang kedua pula ialah glaze tile, refractory dan brick. Bagi glaze tile, bulk density ialah 0.21, Untuk apparent porosity pula ialah 0.87, refractory 0.07 bagi bulk density dan 0.96 bagi apparent porosity. Bagi brick 0.04 bagi bulk density dan 0.87 bagi apparent porosity. Jadi saya akan beralih pada soalan yang disediakan. Dia kata, a ceramic specimen has to be immersed in boiling water to ensure water penetration in the process. State an alternative. Saya akan suggest ultrasonic submersion, iaitu the specimen is submerged in an ultrasonic box which vibrates the water with ultrasonic sound, ultrasonic vibrations. This ensures that the water molecules are absorbed into the pores of the materials. Keempat pula ialah state one equipment to measure density. One equipment to measure density besides using the Archimedes principle is the density meter, which comes in many variety shapes of sizes. Final question is how to measure density of a powder. The density of a powder can be measured by using a certain method. Firstly is to measure the mass of the specific powder itself. Then is to put the powder into a fixed container, which is firstly the container is measured for its own mass. Then added with the powder, the container is then measured with the powder inside. Because density is derived from mass over volume, thus the density of the powder can be measured by just using those methods. I'm Yunus Nabil, thank you very much.
Assalamualaikum and hi, my name is Muhammad Azim Arifi bin Muhammad Ramzan. My metric number is AA1900812. So without further ado, today I want to present to you about the procedures and conclusion for the Engineering Laboratory 1 subject code DAM21603 for experiment of porosity and density. So as you can see here, we have the test procedure for the experiment of porosity and density, and in this experiment we have two parts actually. Alright, so the first part is for metal or glass specimen, and the second part will be for ceramic specimen. Alright, without further ado, we take a look here. We have to assume that the block metal specimen is not porous. Alright, so this is the first step that you have to do, which is you have to assume that the block metal is not porous. And then we take a look at the first step. The first step is the block is weighed to the value of 2 decimal place, which is 0.01 gram, and the weight will be assigned as WD. Right. The second step is the block is tied with a thread and the sample are weighed while suspended in water, and it gives us the value of water density here, which is raw water equals to 1.00 gram over cubic meter. Right, and this particular weight will be assigned as WS. And the third step is the sample are taken out from the water and weighed while it is suspended in air, and this weight will be assigned as WW. Moving on, the edge of filter paper is used to dry residual water on the surface before weighing. So the purpose of using the edge of filter paper is so that we can absorb additional water that available on the sample, because we don't want the weight of the water adding up to the weight of the sample. We just want the weight of the sample. Therefore, we have to dry up any available water on the sample before weighing the sample, right? So the last step is the weight of each specimen are taken and the information in table 1 are filled up. Right, so yeah. Alright, moving on to the second part of this test procedure, we have the procedures for ceramic specimen. So there's a disclaimer here, which is this specimen consists of closed and open pores. Only the volume of open pores is bounded for direct measurement, whereby the air in the pores is replaced with water. For this experiment, the specimen used are tiles and refractory. and below are the experimental procedures. So we take a look at the experimental procedures for ceramic specimen. The first step is the weight of dry specimen, which will be assigned as WD, is recorded. Alright, so this is the basic step. We have to basically just record every single weight of the specimen. And the second step is the specimen is put into water and assured that it is suspended. Right, so you have to assure that the specimen is suspended, and the specimen is suspended in boiling water for approximately 10 minutes to allow water to penetrate into the pores of the specimen. So we have to make sure that this specimen is soaked inside the water for 10 minutes so that we can assure that the water is 100% penetrated into the pores of this specimen. And the third step is the specimen is taken out from the boiling water, and while it is suspended in water, the weight of the specimen, which will be assigned as WS, is recorded. Alright, so we have to record another weight here. And the last step is the specimen is suspended in air and the residual water is removed using the edge of a filter paper. So this one is the similar step as the last step of the first part of this test procedure, which we use the edge of filter paper to dry out any residual water available because we don't want any additional weight on the specimen. And then the weight of the specimen, which will be assigned as WW, is recorded while it is suspended in air. So that's all for the test procedure for ceramic specimen. So what we have here is the schematic diagram of the experimental arrangement for our experiment. So we have apparatus like glass rod, beaker, weight balance, water, thread, and specimen. And this is basically the arrangement of the apparatus and materials that we have to keep it in this experiment. So basically what this whole sentence is saying is materials like metals, glass, or ceramic, we can determine the porosity and density using Archimedes' principle. And generally the porosity of a material using the immersion technique that we've done inside this particular experiment, and that's how you determine the porosity and density value of a particular materials like metals, glass, or ceramic. So that's all for me, and thank you